Welcome to Technology Point. Today I will tell you about nanotechnology. Firstly, what is nanotechnology? Nanotechnology is the science and technology of small things, that it's a technology conducted at the nanoscale, which is about 1 to 100 nanometers. Nanotechnology mainly consists of the processing of separation, consolidation, and deformation of materials by one atom or one molecule. The father of nanotechnology is Richard Feynman. He is the first to talk about nanotechnology. The ideas and concepts behind nanoscience and nanotechnology started with a talk entitled "There's Plenty of Room at the Bottom." In his talk, Feynman described a process in which scientists would be able to manipulate and control individual atoms and molecules. Over a decade later, in his explorations of ultra-precision machining, Professor Norio coined the term nanotechnology. Can you imagine how small the nanoparticle is? 1 nanometer is a billionth of a meter. A sheet of newspaper is about 1 lakh nanometers thick. On a comparative scale, if a marble were a nanometer, then 1 meter would be the size of the earth. Nanoscience and nanotechnology involve the ability to see and to control individual atoms and molecules. Everything on earth is made up of atoms. The food we eat, the clothes we wear, the buildings and houses we live in, and our own bodies. But something as small as an atom is impossible to see with naked eye. In fact, it's impossible to see with the microscopes typically used in a high school science classes. The microscopes needed to see things at the nanoscale were invented relatively recently. It wasn't until 1981, with the development of the scanning tunneling microscope that could see individual atoms, that modern nanotechnology began. In the fabrication of the nano objects, there are mainly two approaches: top-down approach and bottom-up approach. In top-down approach, nano objects and materials are created by larger entities without bouncing its atomic reactions. The most common top-down approach to fabrication involves lithographic patterning techniques using short wavelength optical sources. A key advantage of the top-down approach as developed in the fabrication of the integrated circuits is that the parts are both patterned and built in place, so that no assembly step is needed. If we see in the bottom-up approach, different materials and devices are constructed from molecular components of their own. They chemically assemble themselves by recognizing the molecules of their own breed. As the component size decreases in nanofabrication, bottom-up approaches provide an increasingly important complement to top-down techniques. Inspiration for bottom-up approaches comes from biological systems where nature has harnessed chemical forces to create essentially all the structures needed by life. These are all the applications of nanotechnology. It can be used in optical engineering, bioengineering, nanofabrics, nanodevices, medicines, drugs, and even in cosmetics also. Now let's talk about some of the applications. Inexpensive space travel. With a planned minimum bandwidth of 1 kilobyte per day, the technology is correspondingly cheap. In fact, constructing small satellites is now such a routine matter that it's more expensive to put a satellite into orbit than to make it. This technology may provide solutions to meet demand of safe water, energy, healthcare, and food products with less labor and limited land at low cost. It can be found in many cosmetic products also. like moisturizers, hair care products, makeup kits, and sunscreens. Not only in cosmetics, most of the products we are using in our everyday life, the nanotechnology is using nowadays. Nanoscale additives to fabrics can provide lightweight, ballistic energy deflection in personal body armor, or they can help them resist wrinkling, straining, and bacterial growth. And they are beginning to enable washable, durable, smart fabrics equipped with flexible nanoscale sensors and electronics with capabilities for health monitoring. And in IT sector also, this technology has greatly contributed to major advantages in computing and electronics, leading to faster, smaller, and more portable systems nowadays we are using. For example, like transistors, the basic switches that enable all modern computing have gotten smaller and smaller through nanotechnology. The another main application is nanorobotics. It is the technology of creating machines close to the scale of nanometer. That means these are the devices ranging in size from 0.1 to 10 micrometers and constructed of nanoscale or molecular components. Truly revolutionary nanotech products, materials, and applications are years in the future. What qualifies as nanotechnology today is basic research and development that is happening in laboratories all over the world. And in the bioengineering, diagnostic techniques, drugs, and prostheses and implants, this nanotechnology is using. Interest is booming in biomedical applications for use outside the body, such as diagnostic sensors and lab-on-a-chip techniques, which are suitable for analyzing blood and other samples, and for inclusion in analytical instruments for R&D on new drugs. And for inside the body, many companies are developing nanotechnology applications for anti-cancer drugs, implanted insulin pumps, gene therapy, etc. If we come to the advantages of nanotechnology, there are mainly in three areas: material, industrial, and medical. As we already discussed, by using the nanotechnology in the materials and products, they can become stronger, lighter, cheaper, and precise. And in the industrial area also, computers can become a billion times faster and a million times smaller. And also the manufacturing at almost a low cost. And in the medical science also, these nanoparticles are used in the treatment of some diseases like cancer, heart diseases, etc. Like this, there are so many of advantages, and the disadvantages of nanotechnology also can't be ignored. If we see, increasing development and instant performance have also increased the fall of certain commodities like diamond and oil. And another disadvantage is, with the advent of nanotechnology, it's become so easy of the accessibility of atomic weapons. As I already told, these nanoparticles are used in the treatment of some of the diseases. With that, it also increased the chance of the health issues, like due to the microscopic size of nanoparticles, it increases the risk of inhalation that can severely damage lungs and could also lead to fatal health issues. Nanotechnology has raised the standard of living, but at the same time, it has increased the pollution in water and air also. The pollution caused by the nanotechnology is known as nanopollution. Such kind of pollution is very dangerous for living organisms underwater and on earth. These are some of the disadvantages of nanotechnology. Anyway, if you take any technology, the both advantages and disadvantages. Today's scientists and engineers are finding a wide variety of ways to deliberately make materials at the nanoscale to take advantage of their enhanced properties. In this way, we can see that nanotechnology is about to affect almost every field of human life. We have great opportunities to make things smaller in size, lighter in weight, and stronger in strength. The next big thing is really small. Thank you.